assistant professor at the Yale School of Public Health, where I teach courses in epidemiology and statistical programming, specifically for master's students and doctoral students. I just started working at Yale last year in 2019, but I've actually been a part of the Yale community for a really long time. I actually got my undergraduate degree at Yale in biology in 2010. I went off and worked for a little bit at the National Institutes of Health. I was doing research in genetics for 2 years, but then I went right back to Yale to finish a master's degree in epidemiology. And they convinced me to stay for another degree. So I got a doctoral degree in public health and epidemiology from the Yale Graduate School of Arts and Sciences. I finished last year. So when I'm not teaching, what I spend most of my time doing is doing research in human genetics. The study or the field of human genetics focuses on using statistical analyses to identify the parts of our genetic material, of our genetic makeup, our DNA, that make us different from one another, that are responsible for the differences that we see in people's height and people's hair color, our eye color, and other traits, including, how likely we are to get different diseases. So what I've been doing since my master's is actually conducting research that uses statistics to identify the genes that make people more likely to gain weight over time, to become overweight or obese, and that make it difficult for people to lose weight, even if they lead healthy lifestyles. If they eat a healthy diet or exercise, they still have a hard time, and genetics has a lot to do with it. Later on in today's session, I will tell you a little bit about how I use statistics to help me in my research. So now that you know a little bit about me, I want to tell you a little bit about my university, about Yale. Yale is one of the oldest colleges in the United States. It was founded in 1701. We are located in a city called New Haven, Connecticut. This is just 2 hours away from New York City, which you guys might be familiar with. Yale is a really, really large university. It has, a wide array of programs, different departments, different schools. It includes Yale College, which is where the undergraduate programs are. It includes the Yale Graduate School, where we house our master's students and our doctoral students. And we also have a wide range of professional school programs. We see architecture, art, divinity, drama, forestry and environmental studies, law schools, management, medicine, public health, music, nursing. So we have a little bit of everything. But since you are all in high school, what is next on your horizons, what you're doing next is pursuing an undergraduate degree. So I wanted to tell you a little bit more about Yale College specifically. So here's a little bit about Yale College. Yale College has approximately 6,000 undergraduates, and students come here from all over the world. We have, about 10% of our population is international, and we have representation from over 120 different countries. Okay. Yale is known because of its commitment to what we call a liberal arts education. What this means is that students think and learn across a lot of different disciplines, liberating or freeing the mind to its fullest potential. So the idea is of such an education is not really what you study, but the result of your studies. What we want is for you to have the ability to think critically and independently, and to write, reason, and communicate clearly. So anything you want to learn here at Yale, you can do that. There's 80 different majors, 2,000 different classes to choose from, and you get to basically have your pick at it. You get to design your own curriculum. There's also a lot of different ways to get involved around campus. We have over 100 different athletic teams, 50 different performance groups, 60 cultural organizations. So why am I telling you all this? Because, you know, as you are thinking about applying to college in the near future, I really hope that you will consider Yale the way that I did many years ago. And as your teacher, I'd be happy to serve as a resource during the application process. You can ask me any questions that you want about Yale. Okay. So now I want to shift gears a little bit and talk about why we're all here today. Because in our iStar class, in our iStar statistics class, what we're going to be doing is diving into the world of statistics. So before we do all of that, I kind of want to hear what you think statistics is. What is statistics to you? Type it into the chat. We'll take like a minute or so to do that. And it doesn't have to be right or wrong, just write your thoughts about what you think statistics is. Okay. I see one comment from Leo. Let me see about that statistics is about description and prediction of data. Okay, another one from Gavin. It could be a subject about analyzing data. Larry says collecting data and calculating to get the necessary information. These are all great responses. Joy says using math to predict the probability of different outcomes. Fantastic. Any other thoughts? Well, if nobody wants to add anything to it, this is totally fine because you guys are 100% correct. That is what statistics is. Here's my formal definition of statistics. It's just the art and science of learning from data. So you all in your answers talked about math, data, numbers, okay, and learning from it, making decisions about it, about certain things with data, or making predictions, okay? And so I have one more question for you guys before we take a little bit of a break. Well, actually, I'm getting ahead of myself. Let me give you a little bit more details about what statistics entails. So statistics, basically, the very first thing that we do or that we want to nail down is how to use proper methods to collect data. This could be, you know, using surveys or phone interviews, or maybe doing some sort of biological assays to get different types of data, different information or observations from people or other subjects. The other thing we want to do, or that statistics involves, is helping us figure out what are the right or correct, most appropriate methods to analyze these data. And the last thing is to, you know, help us figure out what conclusions we can make from our data, how we can interpret this correctly, and how we can convey that information to other people. All of these three things, that is what statistics is all about. Okay, so then, I have a chat here. Okay, sorry, this is just Shirley translating for me. Thank you, Shirley. So the last thing I want to do before our break, like I said, was ask you another question. Why do you think statistics is important? Or another way to think about this question is, how would you use statistics? How do you think statistics is used? And you can type that into our chat. Okay. I'll give you guys a little bit more time. Okay, I have 2 responses so far. Ooh, oh, they're all coming in at once. This is fantastic. So Melody says that, that statistics is useful because it helps us make predictions. Leo says, so that we can draw conclusions from a sample to generalize it to a bigger population. That's great. Gavin says it can be used to process a huge amount of information and data to get a big overall picture. Jawei says, like this time we can use statistics to predict the cases of coronavirus. Absolutely right. Flynn says to help us draw conclusions from information. And the last person says to help us close to the reality and make the right decisions and strategy for future action plans. Oh my God, you guys are so good. So yes, these are all, many of the reasons why we care about statistics and why learning the foundations through a class like this one is going to be so important to you guys. So my response to this was not as detailed as yours. It was very, very sort of just big picture. It is the crucial process behind how we make discoveries in science. I use it as a genetic epidemiologist. I use it all the time in my science to make decisions based on data, to make predictions. So what I want to show you in this second part is the fact that statistics is used in a lot of different fields. This is going to be your gateway to making an impact in a lot of different careers and a lot of different areas. So this is just a sample of the many different fields that use statistics, anything from agriculture, biology, chemistry, computer science, economics, engineering, government, health sciences, marketing, medicine. The list goes on and on and on, okay? And so what I wanna do is actually show you some examples of how we use this, how we use statistics in epidemiology, which is my field, specifically in genetics, also in medical clinical trials, in engineering, and in public health. Okay, so the first example here that I have is how we use statistics in genetic epidemiology. Again, this is what I do in my research. What genetic epidemiologists would do, or how we would use statistics, is to help us identify mutations that make people more susceptible to developing some disease. And so what I would do is actually study 2 groups of people. You would look at people who have the disease and people that don't have their disease, collect data from them, collect their DNA information, and then examine their DNA sequences to see where there are differences from person to person. These differences are called genetic variants. So you can see, if we look at these sequences right here, the parts in black are where people are exactly the same, but this part right here, this variant, is where there are differences. Some people have an A, some people have a G in the sequence. Over here, and then people that don't have the disease, most people actually have a G, and only one has an A. Okay, so what we would do, or where statistics would come in, is to help us look at the frequency, compare the frequency of the A's and the G's in the 2 groups. So what do you guys see here? Where is the A allele more frequent? In the disease or no disease group? In the diseased. So A could be considered, someone asked the question, A is bad. Okay, so the A allele, the A version of the DNA sequence, would predispose people to having this disease. This could be coronavirus, this could be obesity, it could be heart disease. Whatever disease these people have, that's what this A allele, a variant, would be associated with. And the statistics would help us make sure that these differences are statistically significant and hopefully clinically relevant so that we can do something to target the specific region of DNA. Awesome. So then, statistics is also used in clinical trials. People that run the clinical trials, these could be epidemiologists, medical doctors, statisticians are involved. They use statistics to help us evaluate the efficacy, how well a therapeutic intervention actually works. Okay, so the investigator, this person right here, would randomly assign subjects to two different groups. So they assign people into two different groups. This group right here, I'm giving it the drug with the label A. These people right here, I'm giving them the drug with the label B. So it's two different drugs. And what we're gonna do is follow them over time. As time goes by, actually see who recovers from the disease or doesn't. So the people that stay in the black color right here do not recover, recover from the disease. These people actually die with the disease. The ones over here in black in group B, again, are the ones that recover from the disease. The ones in green actually die from the disease. So 2 die here, 4 die over here. Which drug is better? Can you guys answer that just from looking at this? Okay. So Rain says A. Leo's asking, isn't this unethical though? What do you mean? Why would you think it's unethical, Leo? No, B is not poison. B is not poison. So the idea is that this could be a disease that if untreated, people are going to die from it. So what we want to do is reduce the proportion of people that die. Okay, so actually making them get cured or get a cure from this disease. So here we have more people get cured. Here we have more people that die because the drug did not work. So we're not giving them any poison or any harmful agents. We're giving them 2 different drugs, and through statistics and by observing their outcomes, we can see which drug has the better outcomes for people. Because you're right, it would be unethical to give them something that we know is bad. We would give them something where we think there is potential, and we want to generate data and use statistics to help us figure out which of the 2 treatments would be better. Do you guys have any questions about this? Well, what if they give another group of people drug C and they all die? IRB might reject this experiment. The IRB could reject this experiment. I am not, telling you any information about, the drugs themselves, any sort of other previous knowledge on this. It is, if I were to just, write a protocol for something this simple, there has to be oversight from some IRB, like you're saying, some sort of group of people, doctors, statisticians, other scientists that make sure that my experiment is not going to harm anybody, because we would not be allowed to do anything that harms them. The goal of these experiments is not to harm people, it's to prevent them from dying from their diseases. Okay. I hope that makes it clear for everybody. And where the statistics comes in is so that we can validate what our eyes are telling us. Our eyes here are telling us that people in group A do better than group B. We would need some sort of statistics to back that up so that people would go on to promote treatment A as the better treatment. This is a really good discussion. Thank you for partaking in that. So the next example I have for you guys is the use of statistics in meteorology. So if you've ever seen the news, whether you're a weatherman or weatherwoman, the meteorologists are using statistics to make predictions about our weather. What they do is they build statistical models based on different mathematical equations that help us understand how air moves and how heat is exchanged in the atmosphere. And they take observations based on the pressure, wind, temperature, and moisture that they get from ground sensors or different weather satellites, and they put that data into the equations. And through that process, they're able to make predictions about what's going to happen, when or where hurricanes like this one are going to make landfall, for example. Here we have a picture of the United States, and here we have the Atlantic Ocean, and these different colored lines are different predicted paths that a hurricane could take. And so depending on how people build their models in statistical models, they might have different predictions about where the hurricane is going to go and how quickly. Okay, so all statistics is powering all of these predictions. One really, really famous example of the importance of statistics comes from the field of engineering. Okay, so engineers at NASA actually use statistics to determine what seem like simple things, what the probability that a shuttle launch will actually be successful. Okay, so in 1986, there was a really terrible accident that happened with a space shuttle called the Challenger. We can see the Challenger exploding here in this picture. It actually exploded only 73 seconds after launch, killing 7 astronauts that were on board. And so this accident is thought to have happened because NASA decided to launch the shuttle in very cold weather. It was 29 degrees Fahrenheit, which is equivalent to approximately -1 degree Celsius. And this happened, they decided to make the launch without carefully analyzing performance data, low temperatures. So what I'm showing you here in this top plot is on the x-axis we have the temperature, and on the y-axis we have the number of incidents. So the number of malfunctions in a particular part of the shuttle that occur or that have occurred in the past at these given temperatures. Okay, so we have, here at 52 degrees, we have about 3 different incidents. Here at 70 degrees Fahrenheit, we have about 1 incident. So using these data, the astronauts actually, or the engineers actually said, I don't have any evidence to suggest that if the temperature is really low in this direction, that there would be any incidents. I don't think we have anything to worry about. And they went ahead with the launch. But, upon investigating a little further after the accident happened, people actually found out that this graph was missing a big part of the data. They actually had excluded data points that where, in temperatures where there had been absolutely no incidents. So we can see that from here, 65 degrees to 80 degrees, there's a lot of data suggesting that no incidents would happen. And so people have analyzed this larger data set with more data points and have actually calculated that the probability that the accident would have happened was 99% at that temperature. Okay, so the moral of the story is that using the proper data and proper statistical analyses would have prevented this disaster in 1986. Okay, so that's why statistics is so important. Some of you already alluded to this in our previous discussion, the fact that statistics is also at the forefront of our investigations of the COVID-19 pandemic. Statistics are part of the groups of people that, they track the cases They also make projections or predictions about the cases that we will see in the future, about the deaths that we're going to see in the future, and about how effective our lockdowns and social distancing measures will be in order to flatten the epidemic curves. So what I'm showing you here is, these points in black are our observed data from February all the way until May. And over here, or mid-April, I should say, last week. And then all of this right here are the predictions. So these different predictions are making different assumptions about how well social distancing works. These predictions of lower mortality, lower death, are models that assume that social distancing and lockdowns will work really well. These higher predictions are coming from models that assume that it will not work as perfectly as we would like it to. Okay, okay. So then I really hope that I have convinced you that statistics is absolutely everywhere, that statistics has far-reaching effects on all of our lives. And as I said, taking our iStar class is going to give you the opportunity to gain foundational skills in statistics so that you can begin to make an impact in the fields of your choice. So in our course, just to give you a little bit of a taste of what it's going to look like, we're going to be covering these different topics. We'll talk about types of variables, how to describe data, what is called descriptive statistics, so making plots, making charts, that all goes under the umbrella of descriptive statistics. We'll talk about probability, because a lot of the things that we want to do in making predictions involve probabilities. We'll also talk about what are called random variables, which has to do with sampling, which we'll get into a little bit. So random variables and their distributions, whether it's discrete random variables or continuous random variables. Then we'll dive into making estimates from our samples called parameter estimates, something called confidence intervals, and hypothesis testing. We'll do tests of differences in means, tests of differences in proportions, and we'll also do some model building. We're going to get into how to build models that make predictions using a technique called linear regression. So before we conclude, I want to just end with some reminders. This is going to be a college degree course. So if you take statistics now, you can take those credits with you to college. Okay. And students that do well in this course can actually earn a recommendation letter from me. Another thing that's really great about taking this course now is that our class size is going to be limited to 25 students. A lot of universities are going to have, for intro classes like this, are going to have many more students in a classroom. So you're going to get way more one-on-one attention here than you would in a normal general education course. Lastly, you're also going to have the opportunity to participate in research and write your own research paper. And having this experience is going to strengthen your college applications. So again, this, when you're applying to college, you're going to use a system called the Common App. And there's a section where you can put things like this, where you can say that you've taken college classes before, and this is going to enhance your application, making you look like a more serious and more prepared candidate. You can also, these credits can be easily transferred to your university wherever you end up after high school and counted toward your degree. It's going to help you go into your program and be able to take more advanced statistics classes or other classes in your field. Lastly, I want to point out the fact that we're going to be using the iStar class platform. And so this is meant to make our course more interactive so that we can all, actually talk to each other, and I can get feedback along the way from you guys about your learning, which is really important. So I hope that all of this has been helpful. I really want to see all of you this summer. If you are interested in registering for the course, you can contact iStarClass at the email right here, info@istarclass.com, or you can dial this number 1614-553-8513. And always, for any questions, check out our website here at istarclass.com. Thank you everybody for coming. And now we're gonna open it up for some question and answer sessions. Thank you.
So my question is, like, if we take away the protection, and how do statistics model second waves of COVID-19?
Shirley, do you want me to answer that question?
Okay.
Or?
Yeah.
Yeah, I mean, so I have to admit, I am not an infectious disease epidemiologist. So there's specific, formulas, not formulas, but models with different inputs that go into these models. Whether it be, something like having a vaccine in place, how would that affect it? They try to basically predict that effect. How, the relaxing social distancing, actually going back and opening up businesses, having people go out there with or without masks, all of these things would be inputs. Other things that are known about the virus and how it behaves, whether it be how many people you're likely to infect. All of these things, a lot of our inputs or variables that would be taken into account in these models so that you can predict the cases. I hope that sort of gives you an idea, but it's a lot of different things. It's characteristics of the virus, characteristics of the environment in which the virus can develop, and also characteristics about the host, the people that can be infected with this. How can it help with COVID other than just predict the trend? So there's other things that you may have heard about, is thinking about the hospital capacity, the number of beds that are needed versus the number that we're going to have available. Okay, so I think that's one of the most important things that people are using statistics for, just to figure out how overwhelmed the hospitals can become during the pandemic, and how many more resources they would need to ask for from their governments or other agencies that can provide those resources. That's one thing that I can think of. So Leo says, creating a sample of participants to test the effect of future vaccines. So one thing that, we didn't talk about, and I'm thankful that you're bringing this up, Leo, is the fact that statistics is also being used to, figure out which people are more susceptible to COVID-19. There's a lot of data that that suggests that people that have obesity, people that have heart disease or hypertension, or other comorbidities will have worse COVID-19 outcomes. All of that research is done using statistics. And the last thing, going back to your point specifically, Leo, is, there are trials being done to figure out the best therapies for COVID-19, and whether they be vaccines or other interventions that people are designing to figure out whether the vaccine works or to figure out whether a drug works. All of that is going to involve statistical analysis. So thank you for bringing that up. So someone's asking, write recommendations, would you take the class and do well? Absolutely, yes, of course. That's part of the deal. We hope that you will take it and do well, and I'm here as a resource for you, as not just to write recommendation letters, but as you're thinking of applying to colleges, I hope you will come to me with questions. That's okay, so that's a really good question about the use of recommendations in the future for other purposes. I would be happy to write something for you now that you could store in a portfolio or something and use it in the future. I think a lot of colleges actually, like I know when I was an undergraduate at Yale, they told us to collect or ask for recommendations along the way and for future use. So I think that's totally valid, and I would be happy to do that for you, Larry.